So let's talk about lasers and fabric. Imagine you're pointing a laser at, I don't know, a piece of silk. What's the first thing that pops into your head? Probably a scorch mark, right? Maybe a little puff of smoke? Well, what if I told you that in the world of high fashion and super advanced textiles, there's a way to use lasers that's so precise it leaves no burn marks at all? Yeah, today we're going to dive into exactly how that's even possible.
You're probably picturing that little sizzle, maybe a burnt hole. And you know what? You wouldn't be wrong. That's exactly how older tech worked. But the science has taken a massive leap forward, and it all starts with understanding one simple thing. Not all lasers are created equal. See, the whole secret is knowing that there isn't just one type of laser. In the textile world, it really boils down to two big players, UV and CO2. And the thing is, they work in completely different ways. You got to think of them as specialized tools for very, very different jobs.
So first up, we've got the CO2 laser. This is the industry's heavy hitter, a real power cutter. And then you've got its counterpart, the UV laser, which is all about getting those impossibly fine details. But the real magic isn't just what they do, it's all about how they do it.
So, what is that core difference? Well, it all comes down to one simple thing: heat. One method is all about a thermal reaction, while the other is something called a photochemical reaction. This is the key concept, right here. Are we using a hot knife, or are we using a light knife?
Okay, let's start with the CO2 laser. This is what we call hot processing. It works by focusing a really intense beam of heat to literally melt or vaporize the material right in its path. The hot knife analogy? It's absolutely perfect. It's incredibly precise for sure, but it fundamentally works by applying intense, localized heat.
Now let's completely flip the script. The UV laser is what we call cold processing. And no, that's not just a cool name, it doesn't use heat at all. So how on earth does it work? Well, it fires these super high-energy photons that directly break the fabric's molecular bonds. Think of it like a light knife. It's changing the material on a molecular level without generating all that damaging heat.
And right here you can see the difference side by side. It's pretty stark. The CO2 laser's thermal effect leaves what's called a heat-affected zone. That can cause those hard, yellowed, carbonized edges. But then look at the UV laser. Its photochemical reaction creates almost no heat. The result? A clean, soft edge with basically no damage. The crucial takeaway here is simple. One burns, and the other one doesn't.
And this whole cold processing thing, it's not just a theory. It has totally changed what's possible in fabric design. We're talking everything from creating sustainable, distressed looks on denim to etching these unbelievably intricate patterns on the most delicate synthetic fabrics. So yeah, it's officially time to put that burning myth to rest. So let's just be crystal clear about this. The idea that modern UV lasers burn fabric, it's a total myth. The process is happening on a microscopic scale, just changing the surface of the material without messing with the structure underneath. In fact, the physical impact is so tiny, you often can't even feel a difference in the texture. It's wild. And this is what the actual tech looks like. This is a typical UV laser marking station. I know it might look a little complex, but it's just a really finely tuned machine. Inside that box, there's a whole system of mirrors and lenses that directs that UV beam with just incredible precision, basically turning a digital design into a physical reality right on the fabric.
And it's all run by software just like this. An operator can load up these complex vector files. Think intricate logos, delicate lace patterns. You could even do microtext and tell the laser exactly where to mark. The level of detail you can get here is just something you could never, ever achieve with traditional printing or dyeing.
You know, the benefits of doing it this way are just staggering. Because the mark is literally part of the fabric itself now, it's totally permanent and wash resistant. You don't get any of those hard edges or stiff patches like you would with ink. Plus, it's super eco-friendly. No inks, no dyes, no solvents needed. The process is so safe and non-toxic, it's even approved for marking things like medical devices.
So after all that, it's really clear that this isn't about one laser being better than the other. Not at all. It's all about choosing the right tool for the right job. So here's the simple takeaway. If you need to cut through a thick piece of fabric, or maybe perforate some leather, you want the raw power of that CO2 hot knife. But if you need to add a super detailed logo or a subtle pattern without changing the feel of the fabric one bit, then the UV light knife is the obvious winner.
And all this kind of brings us to a really fascinating question, doesn't it? When your main design tool can literally manipulate the molecules of a material, what really starts to blur the line between manufacturing and pure art? It makes you wonder,
Where does the design end and where does the science truly begin? Something to think about. Thanks for tuning in.